Hi, my name is Chase Cunningham, or Dr. Cunningham. I'm going to run you through a sort of overt demo of this particular approach to the problem we're putting together. Let me know. Fuck, hang on. Hi, my name is Chase Cunningham, or Dr. Cunningham. I'm going to run you through a simulated demo of what we were doing with ZeroQ that I explained in the PowerPoint. Obviously, none of this is production data. Obviously, none of this is scale. None of this is HIPAA. But this is just to get the concept across and kind of show what we're thinking about how we would potentially address the issue. So watch as we go through this. Okay, so this is the dashboard. You can see that we've got a lot of claim information coming in here, different amounts, different statuses, etc. And again, we're just hooking in through a program interface on another application. So easy to get to. As long as they can send and post that data, we can get that data and use it for these purposes. Users, active users, revenue, etc. And all this is changeable. It's just stuff that I kind of threw together for the purposes of generating the demo. You could also see that if we were trying to train our system, we could run some different scenarios. So maybe we have lots and lots of volume, lots of things that are duplicates, different batch sizes. Are things running into each other? Is there severe congestion inside of the system, etc.? But just to give you an idea of how effective this approach could be, I'm going to run it on kind of the worst potential scenario. Lots of congestion, lots of jitter, things aren't going through very well. And we could increase the size of it. Let's just run that. And now what you'll notice is we're running the metrics and we're getting queues going down to 0. Our throughput is about, a few a second. And then we're going to wait for the outcome over there on the back end of this. The latency continues to get better as we do more of these, and you're continuing to basically solve the problem. So there you go. 109 things were processed, about 4 seconds per. 24 of these were blocked. Now, what does that mean? Blocked, that means that there was a weird or strange anomaly that occurred and we have a problem with it we need to go fix. But good thing is we can see like there's a disputed claim. Okay, great. We look at the claim. It's for $6,000. It's disputed. And here's the chain. So like I said earlier about having immutability, you can track all of this stuff and see what's going on and have a really good record of what's going to take place. We're creating a receipt for each one of these. So if you look, here's the receipt with the cryptographic hash, which means that it's basically immutable because this would be stored on a backend distributed ledger system. And then, of course, we've got some other capabilities in here. So we could look at when it settles, how much should it calculate out to. I also have built this particular feature in here of tracing something inside of the system map, and I'll show you what that looks like. But right now, you can just tell we've brought it in and we've validated it, and that's kind of where we're stuck. Now you could go forward and start doing other things off of that, but that's where we're at. So this is a good example of what happens when you process things and they come into the system. But again, that was 109 claims. I processed it in about 5 seconds, and then it basically outputted it and told me what stuff is missing and where we go from here. And you can see I've been testing and messing around with a lot of this data today. Additionally, we could introduce a chaos mode, which would basically throw things through the roof and go sideways. But you could imagine that there would be lots and lots of latency of whatever. The whole point is chaos mode could be used to generate additional learning opportunities for the model itself, so it could get better faster. The system map. So here you can see how all these things actually talk to each other and which things do what where. Provider information, pre-flight checks. Here's all our API stuff, whether we validate, adjudicate, whatever, and then go forward to the green. We can filter all this by who's doing what where. So what makes things settle cleanly? Okay, great. Things are easy. What does an exception look like? This is how an exception is triggered. What does autofix do? Autofix takes those things and fixes them. What does shadow do? This is how we learn. This is how we train the model. And then payment intent. Well, what does that mean? Is it going to get paid, not get paid, et cetera? Can you track all that, whatever? Additionally, on the features of doing cool things, here is basically a method for building batch processing and doing things quicker, better, faster. So you can see right here, there's 100 and 200 records. I'm just going to basically run those and compare. And you can see, how we get better over time. Green is good, and you can see where we're getting better. So the important thing is not all of these are green. The green is based on where you're getting better as you run differential approaches to the problem. And there you can go and see different things that are processing, how fast, the metrics per run, etc. And then where is it finally getting to in the ultimate end of this. Ops dashboard. So how many things are in your queue? What has exceptions? What is their auto settle? This is where the AI side of it, we're settling about 74% of the claims. And then how fast are we doing that? About 14 seconds per. So not bad. And then of course you have your dashboard for whatever things you got here. Now, cool piece is if I hit this run ops walkthrough, what you'll notice is it's basically going to go through and kick me over towards the exceptions. So there we go. Did the ops walkthrough, put the rest of the stuff together. Now I can run chain sweep, which is proprietary. And chain sweep is going to look at all the open exceptions and basically try and fix them. So, notice we say right here, we don't change history. We append corrections, reissue receipts, and then we let everybody know how to fix the problem. So we start the sweep. This is the ML side of it. You can see that basically we have 69 out of the 1,000 plus that we had before that we need to go figure out and have a human manually fix. So here's where we ran into an issue and now we need a human. So all of them tell you the reason why. You could look at different statuses, you could look at different categories, severity, etc. But if you were somebody that was fixing things, all you would have to do is go in here and open the details. Gives you the hash, gives you everything else. You could assign this to someone in your org, and then they could do what insurance people do and basically go forward and process or whatever. And again, you get the settlement contract value and the traceability too. And then lastly, because this is where the cool side of training and ML comes in, is if somebody says, yeah, everything's good, it was just a goof up and we should approve this, all they gotta do is approve it and then it's done. And the great thing is we've created a correction inside the blockchain. And now this is getting better as things go forward. And we can just track it through there. Shadow mode, this is where I'm talking about we're learning. So you can see we're bringing stuff in. We're getting about 52% over time. 48% obviously we're not agreeing to. What is the outcome, the variability of that? And then are we looking at everything 100%? And then you can review this stuff and go forward from here. And the why is this typically going wrong? Is it a clean claim, partial allowance, whatever? And if I run this pilot demo thing, it'll basically kind of generate some of this information and show you what it looks like. So, these are the diffs, 570 claims we tried to process. This is what's going on. This is the impact. This is where it is. And of course, this is all filterable. So if we look at pending, great, there's pending. And then all a person would have to do is go through here and do what they typically do. What changed? Why did it change? What's the amount? What did we calculate should be paid or should not be paid? Then someone would either mark it accepted or ignore, and then they could maybe convert it to accept. The whole point is all of this trains the model. So if I say mark accepted, great. I just train the model that now anytime it sees that stuff the next time around, it's going to mark that accepted because we've validated and verified it. Chain sweep is kind of the sledgehammer approach. So you can see that there's 174 things that aren't correct. There's 174 that our machine learning, because it's been training on its own, has figured out is fixable. And we're going to fix all of that. And then we're going to tell you why over here. And we just need to apply that. And you can set a confidence level. If we want to say, at an 80% confidence level, we're going to fix 102 things. Like what is acceptable to your organization? I don't know. I want 85% correct stuff. So all I have to do is apply this. And basically this is now doing its machine learning thing. You notice that it says it's fixed all the things that were available to be fixed. And it tells you what the batches were and everything that it did fix. And you're able to go off and basically roll through and all your claims are processed. It took that long. And then this is the last piece, which is the auto fix, going forward and doing the auto fix side of things. So down here, these are the claims that actually require a human to validate and verify because something is weird, something's anomalous, different claims, different requirements, different provider inputs, whatever that is. Could be something very simple where they just say, oh yeah, this is right. We should fix this. Great. It's done. Problem solved. Now, again, that trained the ML in the back that it also has been fixed. Or we could go in here and look, what's wrong, what's the details, what's the fix, what's the claim information, blah, blah, blah. And then of course, bad claim number, and you could reject it. And then now we've rejected that claim. But the whole thing is that trained the model. So whatever you put in there is what's going to train the model to do that right the next time around. And a rules engine, which is where we bring in the information from the payer. What are we going to look for? Duplicates, eligibility, fraud, stuff, etc. What's the dollar threshold that we're going to process? And then it's going to tell us how strict that's going to be as we settle this stuff. So this is calculated for about 80% with a 6% exception rate. So you can change these up, and if you change them up in real time, different things. So if you put all these as 100% or as close to 100 as you want, I mean, you're very strict on what's coming through. But you see that all these numbers are fluid and change, and dollar threshold, whatever. Last couple things, pre-flight check. So if someone's going to submit a claim, we'll call it CLM dash 3 mem dash 4 0101 slash 2026 and amount 500 state VA. And then basically all someone would have to do is run this pre-flight check, and that's going to say that this is a correct claim information that's being drafted to be put in the system. And this is just a very few fields. This could have, the whole goal would be to ingest all that information from someone on their claim side of it so that it is populated and make sure that everything is correct. But you know that right here, notice this is Fastlane eligible. So that means that this claim is going to process in a couple of hours tops. And of course, if there's anything wrong with it, it'll tell us what's wrong with it and we can fix it and go, but all we got to do is say submit claim. And now that's off to the queue. And that good claim is being used to train all the other claims so that from here on out, they'll be correct. And then there's my one claim that I did submit, $500, whatever. And of course, you can see everything going on here. So there's, the hashes, I can turn the hashes on. And this is what I'm talking about with that hash value. This is a very long number, and we would store this where it needs to go. And then, of course, we could verify the chain and make sure that everything is correct and validated, etc. And verify the chain, whatever. I'm just messing around with this stuff, so it's no sign receipt, etc. But anyway, that's the whole goal, is to be quick, fast, and in a hurry. Get lots of information, be able to stream that information essentially and process it as fast as possible, and then use anything that's error prone to fix the errors and do that in a continually learning model, and then apply everything out to a ledger so that there is no central database. There's nothing residing on any one machine for someone to go after and compromise, and that your immutability is tracked across all of infrastructure. Thank you very much.